Welcome to this video on frame analysis. We will use Actus Potentia's statics power software to analyze a frame. So we click on the free body diagram button and we start the free body diagram application. This is the workspace, and at the bottom you have several tools with which you can draw a frame and analyze a frame. Let's draw a frame, and so we take a 2-point member, bring it in the workspace, grab this end with your left mouse button and stretch and rotate and put it here. Then we take an L-shaped 3-point member, put it here, drag with your left mouse button and put it here. Then we will put 2 pulleys. So we click on the pulley, bring it here. This pulley is too big, so we want to change its size. And so we click on the Examine Object button, click on the pulley and change its radius from 3 to 2 and accept. We take the pulley, take it in there, grab this cable, make it horizontal, grab this cable, make it vertical, and we take a pin joint button and pin the pulley on the horizontal member. We take another pulley, bring it in the workspace, examine object, change radius to 2, grab the pulley, take it here, grab this cable, make it horizontal, and we are going to join these 2 cables here. We take a pin and join the 2 cables. We take the other end of the cable, take it there, grab this end, make it vertical, align it with the lower member, take a pin joint, pin the pulley, and then we pin the cable to this member. And we also put another pin here to join these 2 members. We take a pin support, put it here, take another pin support, put it here. Now we are going to apply a load on this cable. Click on the load button, bring it here, and turn the load, make it vertical so the load is applied. So now we have a loaded frame and we want to analyze this loaded frame. We click on the free body diagram button, we get the free body diagram of the whole body. These are the 2 pin supports. Here is the load. This is the top horizontal member. which has 1, 2, 3, 4, 5, 6, 7, 8 unknown internal forces. We look at the L-shaped member. On that we have 1, 2, 3, 4, 5 internal forces. So the whole free body diagram has 4 forces. This member has 1, 2, 3, 4, 5, 6, 7, 8 forces, and this member has 1, 2, 3, 4, 5 forces. As you know, to solve a member completely, we can write 3 equations, and when we have more than 3 unknown internal forces, we cannot solve that member. So we cannot solve the whole free body diagram. We cannot independently by itself. We cannot solve this one by itself. We cannot solve this one by itself. Let's look at the solution strategy and find out what the computer program is asking us to do to analyze this structure. Click on solution strategy. Let the computer find the solution strategy. In step 1, the computer is telling us to analyze member HI. So what's happening at member HI? Let's look at the full structure. When we solve member HI, we know this load, so from the equilibrium of member HI, we can determine the tension in this cable. So if the load is 100 pounds, the tension in the cable HI is also 100 pounds. So now we know the tension in this cable. Let's look at the second step. In the second step, the program is asking us to solve member AFH. So let's look at member AFH. This is the tension from the cable, which we know is 100 pounds. So this is the right pulley. With this tension known as 100 pounds, we can calculate this tension and the pin forces. If this tension is 100 pounds, that tension is also 100 pounds. This force from horizontal equilibrium is 100 pounds. This force from vertical equilibrium is also 100 pounds. So this pulley is completely solved. And where is this pulley attached? The pulley is attached on the top member. So now we know these 2 forces where the pulley is attached because we have calculated these 2 forces from the equilibrium of the right pulley. So immediately you see that in this free body, instead of 8 unknowns, now we have 6 because we have calculated these 2 forces from the equilibrium of the pulley. Let's proceed with the solution strategy. Now, in step 3, the computer program asks us to find the force in member FG. So this is member FG. We know the tension in FG from the equilibrium equation for the pulley, and this tension FG is also 100 pounds. Solution strategy. Now, the computer program asks us to solve the equilibrium of pin G. Pin G is here. This tension is already calculated as 100 pounds. So from equilibrium of pin G, this tension in cable KG is also 100 pounds. What happens in the next step? In the next step, the computer program asks us to calculate, uh, establish the equilibrium for member JKL. But member JKL is the other pulley. We already know this tension is 100 pounds. So this tension is 100 pounds. This force is 100 pounds. And this force is also 100 pounds. So these two forces are now known. And these two forces are coming from the pin where the left pulley is attached to the top horizontal member. So let's see what happened to the free body diagram of the top horizontal member. This is where the left pulley is attached. We now know these forces. These forces we already knew from the equilibrium of the right pulley. These two forces we just calculated from the equilibrium equation of the left pulley. And so this free body diagram now has 1, 2, 3, 4 unknowns. What happens to member CDEM? In CDEM, this is where the cable is attached. So we know the tension in the cable is 100 pounds. So this free body diagram now has 1, 2, 3, 4 unknowns instead of 5 because we calculated this as 100 pounds. Solution strategy. Now here in step 11, the computer program asks us to look at the whole free body diagram. We can write 3 equations and write 3 equations for member CDEM. So if we solve whole FBD and member CDEM simultaneously, we will have 6 equations, which means we can determine 6 unknowns. Let's see where these 6 unknowns are coming from. So in whole FBD, we have 1, 2, 3, 4. And in member CDEM, we have 1, 2. These 2 are not new unknowns, so we cannot double count them because in whole free body diagram we had these 2. So we have now 1, 2, 3, 4, 5, 6, not double counting these 2 forces. So when we go to step 11 and write equilibrium equations for whole FBD and member CDEM, we can write 6 equations and determine the 6 unknowns, which are 1, 2, 3, 4, 5, and 6. So now the frame is completely solved. Thank you for watching.